So this week, guys, we are learning about something called the laws of exponents. So the first thing we need to understand is what an exponent is, okay? So exponents are also called powers, or really rarely they're called indices. You will mostly hear me say to the power of 3, or you'll hear me call them exponents. I don't really use the other word. So basically what an exponent does is it tells you how many times you're going to multiply that number by itself. So if I were to give you the example 8 squared, that is the same thing as 8 times 8. So if I were to write something like 2 to the 4th power, that would be the same thing as 2 times 2 times 2 times 2. So you can see that I did that 4 times. And so that would end up giving me 16. Okay? So down here, where I have 3 to the 4th power, you see I've got 3 times 3 times 3 times 3. So 4 times to get 81. Okay? So the reason we use exponents is because it's definitely way easier to write 3 to the 4th than it is to write 3 times 3 times 3 times 3. Okay, so that's the main reason we use those. So looking down here, we have the example of like a to the 7th. So you can see right here, it's way easier than writing out this or even writing something like that. It just makes it go a lot quicker. Okay. So I know we all probably remember exponents from middle school. So now we're going to kind of get into the laws of exponents. So writing down the letters and thinking about it that way is kind of the key to understanding those laws. So for example, if I have x squared times x cubed, or x to the 3rd, that really is the same thing as x to the 5th. And that's because if we look at x squared, that's just x times x, and then x cubed is x times x times x. So when I multiply those by each other, I get x times x, and we'll put that in parentheses, because remember that's x squared, times x times x times x, which is x cubed. And since I have all those x's, I can just go ahead and write that as x times x times x times x times x. And when I count, I have 1, 2, 3, 4, 5 x's times each other. So I get x to the 5th as my answer. Okay? So it's just kind of thinking about how many of each letter you really have being multiplied. So the laws of exponents, they're also called the rules of exponents, come from 3 ideas. And the first one we've already kind of touched on. So where the exponent tells you how many times to use that number when you're multiplying. Something you maybe haven't seen before is a negative exponent. And that means to divide a number, and I'll show you what that means. So if I were to have something like like 2 to the negative 1, that is the same thing as 1/2. Or if I were to have 2 to the negative 2, that would be 1 over 2 squared, which is 1 over 4. Okay? And that's because what this is saying is that this is the opposite of 2 squared. So the opposite of 4, which is, like the inverse of 2 squared, which is 1/4. Okay? And then a fractional exponent. So if you were to have like 1, no, let's not do 1. If you were to have like 2 to the 1/2, that would be the same thing as the square root of 2, okay? So that means you're going to take the nth root of whatever number. So this one's a little trickier because we haven't really worked with roots yet, but once we do some practice, it'll make sense, okay? So this kind of shows you the laws down here, this table. So if you look right here, anything to the first power is always that same number. So 6 to the first power is 6. Anything to the 0 power is 1, no matter what number it is, okay? Anything to the -1 power is just 1 over that number. So here you've got 4 to the -1, and that just changes to 1 over 4. When you have two exponents with like bases, okay? So if you've got 2 x's, or if you have, 2 2's or something like that, and I'll show you an example, you can add the exponents together. So if I were to have something like 2 to the 3rd times, and it has to be multiplication, times 2 to the 4th, I can combine those to get 2 to the 7th, okay? But they have to be being multiplied together. If they're being added together, that does not work, okay? If I have, hold on, I'm going to continue on that. So if I were to have different bases, so if I had like 3 to the 3rd times 2 to the 3rd, I can't combine that because these bases I have are different, okay? So you have to have the same bases or it does not work, okay? And that's going to be true for all these rules that I'm showing you. You have to have the same base. So if you're dividing, so say I have something like 2 to the 7th over 2 to the 5th, you can simplify that by subtracting your exponents. So you can take 7 minus 5, and this will actually give me 2 to the 2nd power. So just up here, where you have x to the 6th divided by x to the 2nd, you can see that they subtracted 6 minus 2 to get x to the 4th. Okay, so that is another rule. So, looking at our next rule, if you have a number raised to a power in parentheses and then it's raised to another power, you multiply those exponents together. So if I had something like 2 to the 3rd and it was raised to the 3rd power, I would write 2 to the 9th, okay? And that's exactly what they did up here. You have x squared, and then that whole thing is raised to the 3rd power. So they did 2 times 3 to get x to the 6th. Our next rule, we have when you have two numbers raised to a power. So that would be like if I had 2 times 3 raised to the 3rd power. Okay, I could write this as 2 to the 3rd times 3 to the 3rd. And that's what they did right here. They have xy to the 3rd power, and you can see they just split it up, and they put the cube on the x and the y. So, and the same rule applies for division. So I'm not going to write another one out for that. You can see right here where they have x divided by y. And all they do is distribute that exponent to the x and the y. And then if you have x to the negative exponent, that is the same thing as 1 over x to that exponent. So if I have 2 to the negative 3, that is the same thing as 1 over 2 to the 3rd power. Okay? And you can see they did that there as well, where they have x to the negative third, and they show you that that is 1 over x cubed. Now, fractional exponents are a little more confusing. So if you have x to the m over n, so I'm going to write out an example. So if I were to have 2 to the 3/4, what you're going to do is you're going to go ahead and draw the square root symbol, and you're going to put the base, which in this case is the 2, in there. Okay? What you're going to do from there is you are going to take the bottom number, which in this case is 4, and you're going to put it right here, saying that you are taking the 4th root, and you are going to take the top number of your fraction and make it an exponent. Okay? So this is saying you are taking the 4th root of 2 cubed. Okay? And this one we're not going to use a whole lot, but it's just really important. So the base is what goes in the square root symbol, the bottom number goes on the outside, and the top number goes on the inside. So we are going to look right here. So this is explaining the law that you can add the exponents together. So we kind of saw that on the top. But just like this, you know, if I have x squared, that's x times x. And if I have x cubed, that's x times x times x. And if I have those two multiplied together like I do right here, that gives me x times x times x times x times x. And if you count, I have 1, 2, 3, 4, 5 x's. So I can write that as x to the 5th because I'm multiplying x by itself 5 times total. Okay, and the same thing goes for the division one. So if I were to have x to the 5th divided by x to the 3rd, that would be x times x times x times x times x over x times x times x. So this is where we would go ahead and start canceling things out. So this x cancels out this one cancels out this one cancels out this one. And now when I look at what I have left, it's just 2 x's times each other, which is the same thing as x squared. So that's the same thing as if I were to take 5 minus 3, I would still get x squared. So that is why that rule works. So looking here, here's the rule about an exponent being raised to another exponent. So if I were to have 2 squared raised again to the 2nd power, I would have x times x, right? Because that's 2 squared, and then we're doing that twice, times x times x. So looking at that, I have x being multiplied by itself 1, 2, 3, 4 times. So that would be 2 to the 4th, which is the same thing as if I took 2 times 2 right here. Okay, so that is why that rule works. So here we have the rule that if you have 2 numbers together, you can distribute the exponent to each number. So I'm going to show you that. So if I were to have 2 times 3 to the 2nd power, okay, that would be 2 times 3 times 2 times 3. So since addition is commutative, I can rearrange the order, and it's also associative, so I can get rid of the parentheses. I could write this as 2 times 2 times 3 times 3. And looking there, I have 2 times 2, so that's the same as 2 squared. And I have 3 times 3, so that is the same thing as 3 squared. So that is why that rule works. So now we have the law that we can do that exact same thing with division, so that's what I'm going to show you here. So if I had 2 divided by 3, and we'll do cubed this time, that means I have 2 divided by 3 once, twice, and 3 times. And when I rearrange everything, that gives me 2 times 2 times 2 divided by 3 times 3 times 3. And 2 times 2 times 2, we know since that's 3 times, is the same thing as 2 cubed. And 3 times 3 times 3, we know, is 3 cubed. So that is why that rule works. Okay? And our last one is the law. This one is confusing. So we're going to take the nth root of x. Okay, so I'm just going to do a couple examples of this one. So I'm going to do 3 to the 3/4. And I'm going to do 5 to the 6/7. And we will do 10 to the 19/23. Okay, so I'm just going to follow the same 3 steps every single time. So I'm going to draw my root symbol. This is called a radical. So you're going to start by drawing the radical. You're going to put the base in the radical. The numerator will be the exponent under the radical, and the denominator is going to be the root outside of the radical, okay? So that's the same 3 steps. So you draw, the base goes in, numerator is the exponent, and the denominator is the root every single time, okay? And like I said, this is the one we're going to do the least with. So here I put 10, my base, in the radical, 19 as the exponent, and then 23